Continuing our discussion of developing exploits from vulnerabilities, we're looking at a pretty simple Python script, and it starts with our favorite style comment, the shebang, that says, please run the Python interpreter. I then import two basic libraries. One of them is the socket library that I need in order to talk on the network, and the other one is called sys. And sys has things such as command line parsing, basic file operations, etc. I then set two variables. I have one called host, and host is set to my IP address for my target. And then I have the port. Default port is 9999. And then I have this little test, and I say, did you pass in more than two arguments? In other words, did you run the command for the script and then have an IP address and a port after it? If you did, I will reset the values. Then I'm going to build an evil script, an evil string to be sent across the socket to my vulnerable server. So I start out with the trun command, and then I have a period. And then I'm going to send a bunch of stuff. Well, what am I going to send? If you do a little bit of testing, what you'll find is that for the trun command, if you send 3,000 characters, it'll crash it. So here I'm going to send 2006 characters. Then I'm going to send something kind of funny looking. And if you decode these instructions, AF115062, these are the instructions that say, please jump to the address stored in the extended stack pointer, ESP, that register. And you might say, what's that all about? Recall when we have stack vulnerabilities with Windows, often you run into a problem where the address for the location of your shellcode on the stack starts with a leading 00. And of course, we can't have zeros in shellcode, as we talked about before, because if there's a 0 anywhere in the shellcode, then the strcpy will stop. So what we've done is located an instruction that has these codes, and this is the address of that instruction. So at address 625011AF, you will find the instruction that says jump to ESP. Following that line, I have a line that says, all right, I'm going to put a little padding in here. How much padding am I going to use? I'm going to use 16 bytes of NOPs, no operation codes. So they're just filling up space. They don't do anything. And we often will see these with our shellcode, and they are called a NOP sled or sometimes a NOP slide. And the idea is if you're slightly off when your code gets executed, it will hit these NOPs first. And then here is the actual shellcode. As I said before, this shellcode was generated by Metasploit and then encoded to help avoid detection as well. When you do that, it increases the size of the shellcode. And sometimes you don't have a lot of space to play with. In this case, we're fine. We have plenty of space that we can inject some shellcode. So now that we've built this big evil string, we have to open a socket. So this call here says S equals socket socket. And what kind of socket is it? It is an internet socket. So its address family, AF, is internet. And what kind of socket is it? It's a stream socket. And that's why we have socket sock stream is our second parameter. We then connect to our vulnerable server. And this looks a little funny because we have in double parentheses our host and our port. We receive up to a K of data. That's our banner. We print it out, and then we send our evil string, and we exit. If I go to my shell and I run this, simple exploit, it tells me, welcome to the vulnerable server. Everything's good. One thing you'll find is sometimes if you have a vulnerability, you can actually run it over and over, and sometimes you can't. In this case, since I am binding to a specific port on the remote machine, it's probably not a good idea. So again, use netcat to go to that machine and to the port 4444. Sure enough, I'm running a shell. If I go back to my Windows machine, you'll see that it's still running. Now, as soon as I exit the shell and I go back to my Windows machine, Vuln server has now exited. And this is a pretty common thing. So often when you're exploiting vulnerabilities, often if you're using a tool such as Metasploit, you will want to immediately migrate into another process space if you can. And the reason for that is you don't want to be inside of a process that somebody might potentially kill.